Включили. Уважаемые коллеги, вот сейчас идет технический перерыв.
dear guests, we're beginning the panel session for the defense of the thesis by Dinh Ngoc Huy. Thesis submitting conformative requirements for the academic degree the candidate of geographical science. The topic of the thesis is Fate of Propagation North Sea Waters, the Bornholm Basin, the period of major inflows based on simulation results. Under order issued by St. Petersburg State University, issued on the 26th of September, by Zakhchuk Evgeny Alexandrovich, Doctor of Geographical Science, Professor of the Department of Oceanology, St. Petersburg State University, having appointed the chairperson of the Dissertation Board. Let me introduce the other members of the Dissertation Board. Vanenko Tatьяна, Doctor of Science in Geography, Professor of the Department of Oceanology, St. Petersburg State University, Radko Valentin, Doctor of Science in Physics and Mathematics, Professor of the Department of Oceanology at St. Petersburg State University, and unfortunately on sick leave at the moment. Livnov Vladimirovich, Doctor of Science in Physics and Mathematics, Senior Researcher in Moscow State University, and one board member is attending session via Skype, Andros Alexey Anatolyevich, Doctor of Science in Physics and Mathematics, Researcher at the Institute of Polar and Marine Research in Germany. Under the federal law, as of August 23, 1996, number 127, on science and state scientific and technical policy, St. Petersburg State University is entitled to confer academic degrees. The corresponding order, the procedure granting academic degrees at St. Petersburg State University, was issued on the 1st of September 2016. Number 68-1. The current session of the Dissertation Board is held in accordance with this order. The decision of the Dissertation Board is valid, providing 2/3 of the appointed members of the board are present. The total number is not to be fewer than 4 people. The Dissertation Board consists of 4 people, 4 of which are present. As I have already said, one of the board members is on sick leave. And Andros Alexey Anatolyevich is attending the defense remotely via Skype. Therefore, we have a quorum. So, the agenda of the session of the Dissertation Board is as follows. The session of the Dissertation Board cannot exceed 2.5 hours. Number 1. The chairman's presentation about the documents submitted by the candidate for degree, their conformity with requirements. The chairman's reply to questions, if any. Number 2. The candidate presentation providing an overview and findings of the research, 20 minutes. Number 3. Questions to the candidate regarding the presentation, no more than 2 minutes for each question. The candidate reply to the questions. Number 4. Reports on the thesis. We have received reports. We have received both internal and external reports. Since all the reports are posted on the website, we will read out all the critical remarks. Now the candidate comments about the report to the thesis and tries to the questions. No more than 20 minutes. Open discussion. The floor will be given to the non-board members of the audience. They can give a brief account of their ideas or ask questions about the research. No more than 5 minutes per person.
7. Итоговые ответы соискателя на
Number 7. Candidates replied to the questions. Number 8. Presentation of the candidate's thesis supervisor. Number 9. 5-minute break for the open balloting. Number 10. Open balloting for counting and recording results in the protocol. 11, make a decision on whether to confer or not to confer the academic degree. And number 12, the candidate flows in speech, no more than 2 minutes. Before proceeding with the agenda, I would like to ask to switch off your mobile phone. Thank you. The panel session of the dissertation board is being recorded and broadcast on the official website of Swedish University and is being interpreted into English. Now, let's proceed with the agenda. So, this is by Dinh Ngoc Huy, submitting conformity requirements for the academic degree of Candidate of Science in Geography. This specialization is to fireable to A. Oceanology, features the propagation of North Sea waters in Bornholm Basin in the period of major inflow based on simulation results. Was approved for defense by the order issued under number 67601/1. The candidate has submitted the following documents to the academic secretary of St. Petersburg State University. Application, the name of the rector of St. Petersburg State University. It was submitted on 30th of September 2017. Copy of her registration certificate. A letter of verification certifying that the candidate is part of qualifying exam. Report of the supervisor, Professor Saryov, Doctor of Science on Physics and Mathematics. List of published works containing 8 items which describe the research findings. 2 academic papers have been published in peer-reviewed journals recommended by the Ministry of Education and Science, and the thesis in Russian and in English. It has a manuscript copyright. The above-mentioned documents comply with Item 12 of Section 3 of the Order on Procedure Granting Academic at St. Petersburg State University. So all the documents comply with the requirements. Now I give the floor to the candidate of the degree.
Distinguished members of the Dissertation Board, I'd like to introduce my dissertation devoted to the future propagation of North Sea waters in the Bornholm Basin period major inflows and simulation results. So the major bottom bolted inflows are the inflows that inflow into the Baltic Sea from the North Sea during 10 to 50 days. During the MPI, the Baltic Sea presents with up to 300 cubic kilometers of saline water, which affects largely an area of parameters of the Baltic Sea. The inflow results in higher water level and intensive barotropic transformation. Then the saline water distributes into the Borehole Basin and triggers water renewal. Bornholm Basin is one of the first basins that is presented to oxygenation and renewal during the MPI period. And therefore, this impacts largely on the overall renewal process. This process justifies the relevance of my dissertation. The subject of the dissertation is the observation of MBI in the Baltic Sea. The objective of this dissertation is to use mathematical modeling to investigate the mechanisms and the distribution of North Sea waters in the Bornholm Basin. So, we focus primarily on the MBI dating back to 2003. The key tasks of the dissertation is to select near-bottom horizontal inflows and to adapt those to the investigated processes. The second task is to investigate the distribution and the transformation of North Sea waters in the Bornholm Basin by way of modeling. The following findings are submitted for defense. The first finding is that the model of near-bottom horizontal flow adapted to the process in the North Sea results in transformation of temperature oxygenation in the Bornholm Basin. Therefore, the relevant equation results us to investigate the features of the barotropic processes during the MBI. Barotropic processes in MBI demonstrate three key components. This allows us to suggest that the distribution mechanisms in the Baltic Sea are transformed by the barotropic and Borehole process. Therefore, to this end, I decided to look at the preservation of the water distribution mechanisms. To this end, we use a unidimensional model presented on the slide. In particular, the solution obtained allowed us to measure specific parameters relevant for the Baltic Sea. I can justly say that the distribution process is performed in a wave-like form. Results in the formation of the next wave. This is what we mean by propagation. This resulted us to obtain a ratio to describe the propagation ratio and the propagation distribution velocity. I also analyzed the barotropic circulation in the Baltic Sea, and to this end I used a two-dimensional model presented on the slide. 340 by 375 knots. That is the size of the region. As a result, used factual data dating back to 2003. The result us to measure velocities of near-bottom inflows. In particular, I demonstrated that the linear velocity in the Borehole Sea depends on the general temperature in the Borehole process. Results that allowed him to measure the square area of the inflow. Second finding is that the near-bottom horizontal inflows allowed us to adapt the processes to the near-bottom mapping and to analyze the salinity and the dynamics of the flow. To To this end, we use the 3D hydrostatic model, which embraces the transfer equation, state equation, and the transformation equation. The second area is located between the upper border and the mid-sea. Each area is presented with transgression from vertical coordinates to sigma coordinates. This model embraces vertical inflows that are the result of natural pumping, and this allowed us to describe the vertical inflows presented on the slide by way of equation. The parameters that are in the equation are responsible for specific mechanisms. The first ones are related to baroclinic parameters and are named as baroclinic components. The fourth is determined by the parameters of the inflow and are called barotropic parameters. The calculation of barotropic processes that are generated by way of near-bottom pumping can be calculated by the transfer equation and the state equation. Near-bottom friction was calculated by a specific ratio, by Acker-Böhmer ratio. The inflow propagation oozed out high salinity water to the horizons, which impacts the overall salinity background and can be calculated by way of the incremental near-bottom inflow. To this end, we used the equation presented on the slide. This slide presents the calculation area and its location. The calculation area is 80 by 100 north horizontally, and the general pitch is 1.8 kilometers and 1.5 kilometers horizontally. This model indicates the initial and the outcoming conditions presented on the slide. The third finding, the structure and the features of near-bottom inflows propagation. The inflowing water, saline water coming from the North Sea, distribute in the Bornholm Basin as a narrow near-bottom inflow. The near-bottom inflow arrives along the isobars and distributes near the shoreline of the Bornholm Basin. Here we can note that the width is expanding with new inflows being generated. The depth is roughly 80 meters, where we see some isobars. Then the inflow expands to 70 meters and generates branches and streams. So the direction is changed to the eastward and then the northward and eastward. And these streams are partially presented in the relevant area. And Slumsky area. We can also see as the inflow follows the isobars and expands with time. The inflow propagates counterclockwise. Here you can see the section the sagittal section of the Bornholm Basin, we can see a higher salinity area at the maximum depth. With time, we can see divergence and convergence processes. This is the main inflow. Then this inflow streams into more dense inflows with higher horizons. We can also see higher salinity that propagates to southward and northward, resulting in the transformation of salinity The calculation shows the barotropic inflows. This barotropic inflows resulted in slower velocity of saline water propagation. This allowed us to assume that in barotropic currents, saline water comes earlier to the Bornholm Basin. Saline waters and their propagation are different. In case of barotropic inflows, we see that part of the saline water arrives to the near bottom areas. The fourth finding, the transformation of temperature and oxygenation of near bottom inflows in Bornholm Basin. Near bottom pumping is the most crucial force in this process. Here on the slide you can see the distribution of velocities in case of near bottom pumping. At the center we can see the area of utmost negative baroclinic inflows, whereas in the periphery we can see vertical inflows. The vertical currents result in the disturbance of surface waters, this is what you can basically see on picture C. This results in the positive disturbance, surface disturbance, which forms the barotropic pressure gradient into a reverse direction. This is what you basically can see on picture G. As a result of near bottom pumping, its impact on the near bottom inflow distribution was insignificant. The near bottom pumping transforms water, near bottom water, to more vertical horizons, which increases the salinity of water. On picture A, you can see the distribution of vertical inflows and the maximum velocities at the frontal edge of the inflow, of the near bottom inflow. The transformation and the propagation of water results in the changed integral salinity. And this is what you can see on picture V. As a result of the disturbances, baroclinic pressure gradient is formed, which triggers baroclinic inflows. The inclination of the bottom results in the secondary vertical inflow, which dramatically changes the vertical salinity. Picture V. Those can be the results of baroclinic topographic waves, wave vortex, or Rossby waves. However, we can see that these local disturbances are insignificant due to low velocities. And the fifth finding, the transformation of temperature and oxygenation of Bornholm Basin waters as a result of MBIs. Temperature transformation resulted in the inflow of cold water due to barotropic currents. Barotropic currents increased the cold water inflow, which triggered several streams of cold water inflows. With time, the temperature became more or less equal. With time, the cold inflow water has filled in the basin. Once it clashes with warm water, it increases the near bottom layer so as to split the Bornholm Basin with the Slumsky Basin. This results in several streams of inflows. On the slide you can see the distribution of oxygen concentration. In red is the area with lowest oxygen. The North Sea waters are highly oxygenated, and this water usually arrives to the Bornholm Basin and oxygenates waters of the Bornholm Basin. This is basically what we can see in the southeastern part of the basin. In the near bottom area, we can see well-oxygenated areas. Here, oxygen distribution is conducive of the distribution of MBIs with high oxygen fraction. In my dissertation, I used mathematical modeling to analyze the MBIs and to analyze the impact of baroclinic and barotropic processes on the inflow events in 2003. As a result, we have the mechanism of how the inflow events were formed in that time. In my research, I also identify such parameters as temperature, salinity, and oxygenation of waters, which can be explained by the distribution of North Sea waters. The innovative idea of the dissertation is that this mathematical model can be successfully used to describe this specific area and to analyze temperature, oxygenation, and salinity by looking at specific factors. Thank you very much for your attention. Thank you so much. Mr. Din, questions to Mr. Din. So can I ask questions, right? Can I ask questions relevant to the dissertation, right? Am I right? Can I write questions? Can I ask questions? Yes, please. My question is as follows. How do you explain the minimum impact of pumping in Bornholm Basin? Whereas, let's look at the White Sea. The modeling results, although the landscape is the same, the pumping had a crucial impact on the overall inflow situation. How do you explain that? Well, the results of my calculation show that the vertical near bottom inflows are insignificant. Those stand low, as opposite to the White Sea, where salinity is abnormal, roughly standing at 1 promille, whereas in the Bornholm Basin, salinity is up to 15 promille. And the White Sea, on the contrary, has different inflows, whereas in the Bornholm Basin and the Baltic Sea, we do not have any tides. Well, this is not exactly what I wanted to hear as your answer, but I got the general idea. So what you wanted to see is the baroclinic gradient in the White Sea is less significant than in the Baltic Sea. And therefore, I mean the baroclinic pressure gradient. That's right, exactly. Thank you. Can I ask a question? Could you please wind back to the slide where you show the final results of your findings, of your theses? Well, let's look at clause 7. So you claim that this model reproduces all of the processes documented. But I failed to see any slide with some specific observations. Well, these are the results of my observation. Those observations were done by the Polish Academy of Sciences. These results, these observation results, have been referred to in my dissertation in the initial part. Those are the observations done from a vessel, from a sea vessel, so on-field observations. The results suggest that that salinity water arrives from near bottom layers, and this suggests that here you can see just the observation results in detail. I've got another question. May I? Yes, please. You're welcome. On the slide, you show a formula 2.15. This is the continuity equation. Just a second. 2.11. Equation 2.11. The barotropic adjustment processes. In the continuity equation, you have the right part as well. Have you assessed the tolerance? So what is the tolerance for salinity, for density in such divergent equations? You've got a divergent equation, am I right? And therefore, you should include the tolerance. Did you assess the error? I mean, the error by what? Well, you've got the continuity equation and you have the divergent right part. And to this end, if you have the right divergent part, it should also include the error. You've got minus WH, right? So what stands behind that? Did you assess the tolerance? Well, I got your question. I looked at the baroclinic near bottom vertical flows. And this is what stands behind WH. The continuity equation describes the baroclinic lines which are responsible for the divergence of near-bottom horizontal inflows. Therefore, this velocity is the source of disruption resulting in barotropic adjustment processes. That's clear. But in the continuity equation, you have this source. Did you assess the inaccuracy, the fallacy? In that case, did you assess the fallacy? Did you estimate it? No, I didn't. This is it. Thank you. I have a simple question. Is it possible to extend these approaches to some other region, to extrapolate them on some other region? And if yes, then what region would you recommend? Would you please once again repeat the question? Is it possible to take these approaches, I mean the parameterization model and Kelvin waves propagation, this is what you have there. Is it possible to extrapolate these tools to some other basin to investigate the situation there? And if yes, then what area would you recommend? Which one would you consider more appropriate? Well, the Baltic Sea during MBIs generates waves. First, those are progressive waves, and then they ease out. Once they're reflected, we have constant waves. And this is because the size of the wave is larger than the size of the Baltic Sea. So this model takes into account the width of the Baltic Sea, and in terms of width, it entails the barotropic Rossby deformation. To this end, you have to be very specific in considering the initial conditions, the initial landscape. So different area would have different conditions and different barotropic Rossby deformation. And the size of the sea should be less than the length of the wave. I have a question as well. Mr. Dinh. So there was the MBI dating back 2003. However, there used to be other inflows. For example, the MBI of 2003, the MBI of 2016, and those were quite strong events. If you have modeled the other MBIs, you would have been able to answer a highly crucial question, whether the water dynamics and the thermocholic structure are similar across these MBIs, or are those different or opposite to one another from one MBI to the other? Why haven't you done such a comparative study? Thank you so much for your question. Well, firstly, initially we looked for information on MBIs that occurred in 1993. Regrettably, these MBIs are very poorly documented. As for the latest events, regrettably, we failed to include these results. Thank you. Any more questions? No questions. Thank you, Mr. Dinh. Then let's move over to the reports. Overall, the thesis has generated 6 reports, 5 reports submitted by members of the dissertation board and 1 external report. Out of the 6 reports, all of them are in favor of the defendant. All the reports were timely downloaded to St. Petersburg University website. Everyone wishing had an opportunity to look at these reports. Therefore, I urge members of the dissertation board to focus on recommendations only. Initially, I would like to start with my report, Professor Roshkov's report, who is absent, and then I would give the external report, and then I would give the floor to those members of the dissertation board who are together with us. So the report is signed by Professor, Senior Fellow, Mr. Tikhomirov.
He mentions that although the thesis gives an in-depth analysis, but he should have given a more in-depth analysis of specific features. So I believe that it would be logical to place the results of the barotropic currents at the beginning of the 2nd chapter. I would like to say that the calculation results should have been compared with the observation data. The theoretical part of the thesis does not give an in-depth analysis of the propagation of the North Sea waters in the Baltic Sea, by which I mean that the section which describes the processes which are caused by the inflow of Danish straits are not compared with the data obtained by other authors. The modeling results of the disturbance of the salinity field are not quite full. I think the author should have demonstrated how the salinity changes on the pictures in the thesis. For example, he could have compared the inflow of the near-bottom flow with the distribution of salinity integrated over the depth. There are some misprints in the thesis. For example, the pictures of barotropic currents during the MBI are not placed on the correct places. The next report is signed by the member of the dissertation board, Doctor of Mathematics and Physics, Professor of the Department of Oceanology, St. Petersburg State University, Rashkov Valentin Alexeyevich. I would like to read out the critical remarks. The thesis describes one example of modeling of the propagation of North Sea waters in the Bornholm Basin, which happened in 2003. However, the author of the thesis refers to 150 theoretical works devoted to this issue, which means that the major contribution to the issue was made by German scientists from the University of Marine Studies in the city of Warnemünde and the same scientists from the University of Kiel. However, the author does not mention their names, including the name of Wolfgang Matthäus, whose contribution was critical to the issue. You are defending the thesis to obtain a degree of the Candidate of Science, but your thesis is based on the model which was developed by your research advisor. Besides, the first research finding to be defended contains the text which is very similar to the scientific novelty of the thesis. So could you please speak about your own contribution to improving the model? The major research findings were published in 2 articles and 6 proceedings of the conferences. Please speak in more detail about these publications which reveal the major research findings. The 2000 inflow was influenced by the meteorological situation as well. However, the thesis does not speak about the link between the meteorological and hydrological factors, and this issue is described in depth in a textbook by Professor Dymnikov, which was published in 2014. However, the reference list does not contain this theoretical work. The next report is signed by the chairperson.
Doctor of meteorological scientist, the acting head of Oceanology Department, Mr. Zakharchuk. Well, the report features the following recommendations. On page 55, the defendant says that due to the fact that the inflows into the Baltic Sea result are triggered by the Kelvin wave, therefore it is difficult to describe this process within the framework of the Bornholm Basin. However, this is not actually what is meant in my work that the defendant is referring to. I believe that the defendant has failed to properly operate the key parameters describing the wave. Therefore, the results obtained based on the analytical analysis cannot prove the hypothesis. It is yet unclear why does the defendant uses numerical modeling to justify his hypothesis. For example, these calculations could have allowed the defendant to assess the nodes of the standing wave. Contemporary research based on analytical calculations and hydrodynamic models evidence that there is large-scale vortex in the inflows, which are comparable to the baroclinical Rossby deformation. According to foreign scientists, this value changes from 1.3 to up to over 3 kilometers. If we look at pictures 3.14, 3.19, we can see that the 1.8 kilometers pitch is insignificant to deliver on the large-scale vortex description. So next, I would like to give the floor to a member of the Dissertation Board, Doctor of Physical and Mathematical Sciences, Senior Fellow of Alfred Wegener Institute, Alexei Androsov. Please focus on recommendations only. Thank you so much. I have several recommendations and points of criticism as well as questions. First of them is whether these models can be justified and applied directly to the natural observations. The pitch of 1800 meters is insufficient. It is unfortunate because this is due to the frontal area analysis. Have you analyzed any other options? Another important dimension in modeling is the friction parametrization. So the Akerblom ratio was used by the defendant. Is it justified to implement this ratio to describe such complicated processes? Regrettably, no numerical algorithms is reflected in the dissertation. The equations reflected on 2.4, 2.6, and 2.10, 2.12 temperatures, salinity, and oxygen are in the non-conservative form. And this complicates largely the stability of the numerical model. The baroclinic pressure gradient is calculated in the Bornholm Basin, and when calculated it should include the two-dimensional barotropic model. I have some recommendations in terms of the text, how the text is done. It has many misprints and inaccuracies. There are no references. The references indicated in pictures 1.1, 1.3, 1.5 are all discrete, so there is no uniformity. Some graphs fail to have the measures of indicated values. Well, some formulas feature mistakes, but the key point of criticism is that you refer to 80 books in your reference list out of 150 indicated. Well, your conclusion? Well, despite all these disadvantages and drawbacks, the dissertation is exciting. It is still fascinating because, as of late, this area is largely susceptible for modeling, and any modeling attempts should be supported. Thank you so much, Professor Androsov. Now I would like to give the floor to member of the Dissertation Board, Doctor of Physical and Mathematical Sciences, leading research fellow of Oceanography, Moscow State University by Lomonosov.
I would like to feature only the drawbacks. So here are the drawbacks. The first one refers to the use of terms. And as far as I understand, the candidate for the degree has already corrected the terms. But in the thesis, the author spoke about the density waters. We can speak about density currents and density flows, but not density waters. But the candidate for the degree has corrected the mistake. Chapter 1 gives an in-depth analysis of the inflow of North Sea waters, which happened in 2003. And I think the author should have focused not only on the description of the event. And here I agree with similar critical remarks made by my colleagues. I think you should have compared your modeling results with the observation data to see how the simulation results are similar to the observation data. There are some mistakes in the captions, especially I would like to mention that some captions have been borrowed from other sources, but there are no references to them. There are some mistakes in the formula on page 44, but I believe that there's a misprint, because according to the formula, the point experiences a simple discontinuity, which is not the case here. And there are some misprints in the text. And sometimes it makes it more difficult to read the thesis. And it's very frustrating, I believe. But I believe that the thesis features of propagation of North Sea waters in the Bornholm Basin comply with the major requirements, and Dinh Ngoc Huy can be awarded the candidate degree of the Candidate of Science in Geography, specialization 250028, Oceanology. Thank you. Thank you for your report. Now I give the floor to the member of the Dissertation Board, Doctor of Geographical Science, Professor of the Department of Oceanology, Belonenko Tatiana. Good afternoon, dear colleagues. I have analyzed my report and I was writing my remarks as soon as I came across some drawbacks in the thesis, so I'm going to read them out. Number 1, picture 1.2, large-scale internal circulation is inconsistent with the text, which speaks about surface and deep water currents. Picture 1.3 is borrowed from another source, and there is no reference to this source. This can be applied to some other pictures as well. Number 3, caption to picture 1.9 reads Rosby Ocean Center, and there's a reference to May 2001. First of all, there is no such item in the reference list, and secondly, the author should clarify what he means by Rosby Ocean Center. Number 4, there are some fragmented sentences which are not understandable. I'm not going to read them out. Number 5, the Archer-Bloom ratio for the tangent lines on picture 50 has a mistake, and parameter alpha also has a mistake. Number 6, the Archer-Bloom ratio is relevant only for the homogeneous layer and not for the water column. Therefore, I don't think that the author should have used the formulas for the current velocity, which can be related to the water column. Number 7, how formulas 2.29 and 2.33 related to the near bottom friction coefficient. Number 8, and here I quote, the thickness of the bottom dense flow was calculated using the integral value of the salinity anomaly in the bottom layer divided by the value of bottom salinity. I don't understand how the author obtained the dimension in meters after such calculations. Number 9, on page 53, I think you're writing about baroclinic and not about barotropic currents, since formula 238 describes baroclinic currents and not barotropic currents. Otherwise, there are some inconsistencies with horizontal currents. There is an error in the mathematical symbol in formula on page 53. On picture 3.4, the cross-sections are not shown. Number 12, I don't understand why you claim that the parameters in formulas 3.6, 3.7 should be similar. On page 61, you are describing the standing wave, and this is not a Kelvin wave, which is a progressive one and propagates in the northwestern hemisphere. Therefore, I think you shouldn't have used the asymptotic condition in the formula, since the Kelvin wave is not described by this formula. Formula 3.14 has an error, as well as some other formulas. On page 62, you are writing about velocity fluctuations, and here I quote, the absolute value experiences a linear growth, but this statement is not proven. And to this end, we can say that the results on picture 3.6 are not correct. On page 69, you use some abbreviations which are not deciphered in the thesis, and it makes it more difficult to read the thesis. And the text is written in a careless manner. There are no punctuation marks and so on. But I can say that I'm not a big fan of the thesis. However, I believe that this is a graduate research work and it complies with the requirements. I can say that the thesis complies with the major requirements set forth in the appropriate order, and Mr. Dinh can be awarded the degree of the Candidate of Science in Geography. Thank you. Now I give the floor to Mr. Dinh to reply to the questions and make comments about the critical remarks.
Well, I would like to reply first to Madam Timokhova's recommendations. In the first recommendation says that there is an insufficient amount of works and references devoted to the inflow waters distribution. The second recommendation, and my reply is that these results are identical to the results obtained by looking at the initial MBI processes, and I accept these events. And I also accept the third recommendation. Whereas the last recommendation, I should say that I accept it as well. My reply to Mr. Rashkov. I accept the first recommendation. Yes, indeed, this process is highly crucial in analyzing the MBIs. As for the second recommendation, I would like to clarify that the distribution process of the near-bottom horizontal inflow is stratified, which means that the salinity is transformed. To consider these factors, I look at the transformation of salinity by way of abnormal salinity, which means that I split the background salinity and the abnormal salinity. I also take into account the transformation of temperature and oxygenation, the barotropic currents, as well as the near-bottom horizontal inflow distribution. The third recommendation, well, these provisions are published in a relevant journal. The proceedings of the Russian State Hydrometeorological University number 46 and 47 included in the list of journals registered with the Higher Attestation Commission. The first paper is devoted to the barotropic currents in Bornholm Basin, and the second paper looks into the distribution of near-bottom horizontal inflows in North Sea during 2003. I accept the fourth recommendation. Yes, indeed, wind can transform the distribution pattern of near-bottom horizontal inflows, but we did not consider this aspect in this research. My reply to Mr. Zacharchuk and his recommendations. As for the first recommendation, on page 55, well, I generally accept it, and yes, indeed, here we can note that the gravitation waves are there. I accept the next recommendation as an error. As for the next recommendation, well, these results were obtained that the pitch in the grid was insufficient. Well, I accept it as a point of criticism, but the larger the pitch, the larger the curvilinear grid, and this actually interfered into the calculations, making them otherwise impossible. My reply to Professor Androsov. Well, the first statement, well, the majority of models consider that the horizontal inflow dynamics are largely influenced by primarily the pressure gradient and the bottom inclination, as well as Coriolis forces. It is believed that the near-bottom horizontal dynamics is lower than the latter two factors. I did not do the analysis pertaining to your second comment, and therefore I believe that it is viable. The third commentary, and therefore my reply, the Eckerblom model describes the vertical inflow structure in near-bottom Ekman layer. And the near-bottom layer with the depth of over 1 meter, this condition is justified. Therefore, the Eckerblom ratio is justified as well. The fourth recommendation related to the algorithms, those have been described repeatedly in the dissertation by Nadezhda Podrezova. Therefore, I do not refer to these algorithms in my dissertation. The fifth recommendation related to salinity distribution equations. Well, my focus here was the diffusion and the distribution factor. The relevance of the results was determined by way of calculations. So we focused on the overall saline mass, as well as the structure of near-bottom inflows distribution. This equation, I'm referring to your sixth point, cannot be assessed in these terms, and the relevance of this calculation can be assessed by way of the model example at this particular area. The next commentary relates to the near-bottom horizontal flow and the barotropic currents. Here I used the dimensional model. So as for your 8th recommendation, I accept it. My next reply is to Mr. Rosen. Well, I accept your first recommendation. I accept your second recommendation. As for the third recommendation, well, that was just a misprint. I accept it. As for the fifth, well, here the two calculation areas split in two calculation grids. Therefore, Z is equal to 1H. This is the threshold of the bottom layer. As for the sigma 2 equals 0, this is the upper border, the upper margin of the near bottom layer in the grid. The fifth recommendation, well, I accept it. As for the recommendations by Tatiana Belonenko, the illustration 1.2 is the basic it's a basic scheme that features the surface and near bottom flows in the Baltic Sea. For example, the vertical advection and the transgression. As for the second recommendation, I accept it. I accept the third recommendation. It was a misprint in this illustration. As for the fourth recommendation, I accept it as a misprint. And here you should have the word calculations instead of for the sake of calculation. And the fifth recommendations, I accept it as a misprint. The recommendation number 6, I should say that the Eckerblom model reviews the near bottom Ekman flows that are responsible for the unchanged gradient, vertical gradient, I mean, and the pressure gradient has to be higher than the inflow gradient. 2.29 formula is generated by half empirical ratio for near bottom flows, whereas the 2.36 formula expresses the coefficient of near bottom friction and is derived from the Eckerblom ratio. Those are two different waves. Point 8. The integral abnormally of salinity is the integral salinity of the density inflow. Therefore, it is measured in promille per meter. The integral salinity anomality depends on the abnormal salinity and the depth of near bottom layer. So the next recommendation, well, I should say that this has gradial barotropic inflows, and this reduces the surface vertical flows. These vertical flows generate the disturbance area that results in baroclinic inflows, whereas the formula 2.38 expresses the linear decrease in vertical inflow velocity. Surface wards. As for recommendation 10, I accept it. Recommendation 11, I accept it as well. It was a misprint. You should have had the section, the cross section, instead of the dots. As for the 3.6 and 3.7 ratios, those are derived from the wave equation, taking into account near bottom friction. 3.12 equation are derived not for Kelvin's waves, but for basic gravitation waves. The Baltic Sea and the inflows in the Baltic Sea are not higher than the barotropic radius of Rossby deformation. therefore we can allow some adjustment for the 3.12 formula. For low frequency waves, consider those are larger than the length of the Baltic Sea. Recommendation 14, yes indeed, there is a misprint, but actually the essence is the same, the idea is the same. Recommendation 15, this is the conclusion derived from the standing wave equation, that thus is the property of the standing wave, and it implies that the wave is reflected from the border. Recommendation 16, we showed that the results on illustration 3.6 demonstrate the heterogeneity of the disturbance in the Baltic Sea. And with tides, the velocity can be different. Recommendation 617 I accepted. And yes, indeed, the cross-section A to B and V to G on illustration 3.9 is indeed there, but it's not reflected in the text. And I accept the recommendation 18. Thank you. Thank you so much, Mr. Dinh. Please wait. Distinguished members of the Dissertation Board, are you satisfied with the defendant's replies to your questions, or do you have something to add or something to counter-reply? It's all fine. I'm satisfied. Thank you. Thank you, Mr. Dinh. Please be seated.
Are there any questions to Mr. Dinh? Since there are no questions, I give the floor to the research advisor, Professor of St. Petersburg, Professor Tsarev Valery Anatolievich. Mr. Dinh graduated from the Russian State Hydrometeorological University, and I was his thesis advisor. I was the research advisor of his graduation paper, and a year later, after his graduation, he sent me some research which dealt with the oil spill in the Chinese Sea, which means that he tries to apply his theoretical knowledge, and although he did not make any specific research, he was clearly interested in scientific work. And when he was enrolled in a postgraduate course, he asked me to write a thesis about near-bottom inflows and the propagation of North Sea waters. While he was a postgraduate student, he did a great job. It was difficult for him to study, and I think he improved the model that had been developed by our department. The department developed a mathematical model for heterogeneous waters, but he included the stratified water in the model. He also took barotropic currents into account, as well as the influence of the dense inflow on the stratification of water, and I believe he was able to solve all the tasks. For example, while calculating barotropic currents, he resorted to some analytical data. For example, he paid much attention to different types of waves, and he was able to make all the calculations and make his own contribution to the mathematical model, which describes the propagation of the dense water in highly stratified water. And I would like you to vote in favor of the candidate for the degree. Thank you for your presentation, dear colleagues. So, the next point is on our agenda is open voting. First, would you like to say a few words about the thesis? Who would like to say a few words about the thesis? I have already expressed my opinion in the report on the thesis, and the report also includes some points about the advantages of the thesis. I believe it's a very interesting thesis, and the author was able to obtain very interesting and very relevant results, and the defense itself was also highly praised by me. Does anyone else want to say a few words? So my report is in favor of the thesis, and the major part of my report is devoted to the advantages of the thesis. This is the second time I have heard a presentation by Dean, and I see that he has improved his presentation, and I can see that he knows how to present his research findings, although the Russian language is not his native language. So I believe that we should confer the degree to Mr. Dean. Alexey Anatolyevich, would you like to say a few words? I agree with my colleagues. I really liked the presentation by Mr. Dean. I liked it even more than the thesis itself. I can see that you have done a great job in order to prepare this presentation. I also agree with my colleagues, and I believe that this thesis is relevant. It complies with the major requirements set forth in St. Petersburg State University, and I believe that Mr. Dean should be awarded the degree of the Candidate of Science in Geography. So, let's start the open balloting. I would like to remind you that the decision of the Dissertation Board is valid, provided more than 50% of the board members voted in favor of conferring the academic degree. It is in conformity with Section 23 of the appropriate order issued by St. Petersburg State University. So, Balloting Tatiana Vasilyevna, what's your opinion? I vote in favor. Professor Ivanov, how do you vote? I vote in favor. Professor Androsov, how do you vote? I vote in favor. And I, Zakharchuk, Evgeny Alexandrovich, also vote in favor. Now, thank you. So, dear colleagues and guests, out of 5 board members, 4 board members have voted in favor of conferring the academic degree to Mr. Dinh. Nobody voted against and nobody abstained from voting. So we can say that Mr. Dinh Ngoc Huy can be awarded the academic degree of the Candidate of Science in Geography, Specialization 250028 Oceanology. Now I give the floor to Mr. Dinh for his closing speech. First of all, I would like to thank my thesis advisor, Professor Tsaryov. He has been my research advisor for quite a long time. Secondly, I would like to thank the members of the dissertation board for their critical remarks and for their questions. Thank you, Mr. Dinh. So, we're finishing the session. Please switch off the broadcast.